Hi and welcome back. So now in this chapter, let's go through the storage options which are available in AWS, and let's map this to the objectives in the exam. So when you look at the key objectives which map to storage, so we have domain 1, which is resilient architectures. So in here you have one of the objectives as choosing reliable and resilient storage. You also have domain 2, where you have to choose storage which is high in performance, not only for your underlying servers, but also for your databases. And finally, there is also a part of designing cost optimized architecture. So in here also, you will see that there is an option for designing cost optimized storage. So you can see that you have these storage options in 3 of the domains, and it's split between these domains. So you could expect questions which could ask you concepts behind each of these objectives. And you can see there is a large percentage which is dedicated to domain 1 and domain 2. So let's go ahead and understand the different storage options. So first you have object level storage. So object level storage, you have the simple storage service and Amazon Glacier. In block level storage, you have the elastic block storage volumes, which can be attached to your EC2 instances. And then you finally have the databases, which is your Amazon Relational Database Service, DynamoDB, Aurora, and Redshift. Now for me, when I am answering questions, I go through the question over and over again just to get some key terms in the question. Sometimes in the questions you will see design an architecture which has object level storage. So this key term of object level storage should automatically direct your thoughts towards using either the simple storage service or Glacier. So sometimes look for these key terms in the question itself in the exam. This will help you better understand or limit the options for the answers, and then help you pick the right answer in the end. So let's go to object level storage, which is a simple storage service. So when you map it to the first domain, which is resilient storage, remember that the simple storage service has high durability and availability. How does the simple storage service achieve this? Well, when you use the S3 service to upload an object to a bucket, in the background, what the simple storage service does, it actually copies that same object onto multiple physical devices. Only when the copy is done to all physical devices, then you get a result saying that yes, your object is securely stored in the simple storage service. So in case if one of the physical entities goes down, the other ones are still available, and this is how the simple storage service achieves high durability and availability for your underlying objects. So if you're looking for object level storage which has high durability and availability, think of the simple storage service. So we've already looked at the advantages, wherein if one device fails, the object would still be present on another device. One key point to note here is that this replication is only available within a particular region. If you have a disaster recovery scenario in which you have really critical data, so if you have in the question saying it's critical data, it needs to be available all the time, even if the region goes down. Then the simple storage service also has a facility known as cross-region replication for a particular bucket, in which the objects, so when you copy an object to a bucket in one region, it automatically can be replicated or copied onto a bucket in another destination region. This will be done automatically for you. Some key concepts which I hope you have learned in training is that you have to enable versioning on the bucket. This is a prerequisite to ensure that objects can be copied onto another bucket in cross-region replication. Also, if you have already existing objects in the bucket, those will not be replicated. So if you want to have replication for your objects from the very beginning, ensure that you first enable cross-region replication and then start uploading objects in your primary bucket. Now, apart from Amazon S3, we also have Amazon Glacier. So this is used for archive object storage. This is a very cost-effective option if you're looking to archive your files and your data. Now, they have this standard retrieval process from Glacier, wherein after uploading an object onto Glacier, if you want to download the object, you have to submit something known as a job, and then the objects which you want to retrieve would be available after 3 to 5 hours. So this is the catch when you actually have cold storage or archive storage. It is cost effective, but one key thing to note is that if you want to retrieve something back, it takes 3 to 5 hours. This is very important from an exam perspective. So if you have a question wherein it says that it's acceptable to download objects after maybe 5 hours or 3 hours, and you want a cost-effective option, then you can choose Amazon Glacier. But in case if you want to retrieve objects even faster, now there are 2 ways. First thing, there's something known as expedited retrieval in Amazon Glacier. Here you can actually get the objects back in a matter of minutes, but you have to pay extra. The other way, which I don't have in the slide, is that if one of the options in the exam or in the question says that you could use Amazon S3 infrequent access, so Amazon Glacier expedited retrieval is not part of the options of that question, then choose the infrequent access because that gives you cost effectiveness. It also allows you to download the objects much quicker. Obviously, Amazon Glacier is much cheaper than infrequent access, but again, depending upon the options which you have for the question, choose them accordingly. And then remember that to transfer data onto Amazon Glacier, there are 2 ways. Either you could use the API or you could use lifecycle policies which are defined in S3. Remember that you can't use the AWS console to upload objects onto Amazon Glacier. You either have to use the application programming interface or lifecycle policies.